Okay, guys, today we're going to introduce another classification of compound, and that's organic. Okay, so we've already covered how to spot an ionic compound, how to spot a covalent compound, or an acid, and now we're going to add another classification of compound, organic. Now, organic compounds are covalent compounds in that they contain covalent bonds. But it's a whole classification, a whole nother classification of compound. And it's organic chemistry is, there's a lot going on in organic chemistry. And we're just going to kind of scratch the surface of organic chemistry. So we're talking about the simplest, the minimalist thing in organic chemistry. Okay. So this lesson is about just, hey, what does it mean to be an organic compound, and then how to name the simplest types of organic compounds, and those are what we call straight chained hydrocarbons. Okay, so there's plenty other complex naming system for organic compounds, and we're just going to talk about the simplest part of that naming, the naming rules, and just talk about straight chain hydrocarbons. Okay, so hopefully that'll make sense as we go through the lesson. But that's all you'll be responsible for when it comes down to a test or a quiz. You won't have to name a crazy organic compound. And in class, you know, when I show you some of the more complicated organic compounds, that might make a little bit more sense. But again, remember, for you, it's only going to be straight chained hydrocarbons, and hopefully that means something to you after this lesson. All right. So let's get into, first we got to figure out what does it mean to be an organic compound. All right. So here's the deal. To be classified as organic, right? Organic really just means carbon-based. Okay. Have you ever heard of that we're organic life forms? That means we're carbon-based life forms. So organic chemistry is the study of compounds that contain carbon. Okay. Now, technically, to be classified as organic, you have to have carbon and hydrogen. Okay, now you can have some other stuff, okay, but you have to have at least one carbon atom and one hydrogen atom in your molecule, and then your molecule will be classified as an organic molecule or an organic compound. Okay, so you can throw in oxygen in there, you can throw in nitrogen, you can throw in a bunch of other stuff, but if you have carbon and hydrogen, boom, you're going to say organic. Okay, so we have our kind of classification flow chart. If you got a metal or ammonium, you know that's ionic. If you got H in front, you're thinking acid. If you have two nonmetals, you're thinking covalent. And now, if you got carbon and hydrogen, again, it could be some other stuff, but if you have carbon and hydrogen, you're organic, okay? All right, so CH4, organic. How do I know? I got carbon and hydrogen. This compound, this is methanol. Okay, we'll learn how to name that. You won't be responsible for naming it, but you'll be responsible for naming this one, but maybe not this one. Okay, but how do I look at that and know it's organic? I got carbon, I got hydrogen. Yeah, I got oxygen too, but as long as I got carbon and hydrogen, I know I'm organic. Okay, so right now we're going to focus on just hydrocarbons. So what does it mean to be a hydrocarbon? A hydrocarbon only has carbon and hydrogen. So this would be a hydrocarbon. This would not. Okay, they're both organic, but right now we're just going to focus on the simplest forms of organic compounds, and those are the ones that only contain carbon and hydrogen, and that's it. Okay, and we classify them three different ways. Okay, there's alkanes, A-N-E-S. There's alkenes, E-N-E-S, and there's alkynes, Y-N-E-S. Okay, alkanes, alkenes, alkynes. Okay, so a hydrocarbon can be classified as an alkane or an alkene or an alkyne. All right, so let's go through the difference. Okay, so an alkane, by definition, is saturated. We'll talk about what that means in class. Right now, we're really just going to focus on the nomenclature. Alkane means you have a saturated hydrocarbon, but really what that means is all the carbon-carbon bonds, all the bonds between carbon are single bonds. Okay, alkane. All the carbon-carbon bonds are single bonds, okay? So what's an alkene? An alkene is where you have a hydrocarbon where one of the bonds, where at least one of the bonds is a carbon-carbon double bond, okay? An alkene is where you have at least one carbon-carbon bond, but it's a double bond, so 4 electrons being shared. And then you guessed it, an alkyne is a hydrocarbon where at least one of your carbon-carbon bonds is a triple bond, so 6 electrons being shared, okay? So ane means all single bonds between your carbon atoms. Ene means you have at least one double bond. You could have other carbons that have single bonds, but you have at least one carbon-carbon double bond. And alkyne means you have at least one carbon-carbon triple bond. And when it comes down to naming later on, we're going to assume that if it's an alkyne, there's only one of these bonds. Yes, you can have other types of compounds. Other hydrocarbons could have multiple triple bonds or multiple double bonds, or maybe a triple bond and a double bond. You can have all that stuff, but we're going to simplify it, and we're going to say, hey, if it's an alkyne, there's only one carbon-carbon triple bond. If it's an alkene, there's only one carbon-carbon double bond. And if it's an alkane, obviously they're all single bonds, all right? So what does that do? All right, so the first thing we have to know about carbon is carbon in these organic compounds, in these organic structures, have to have 4 bonds, 4 total bonds, okay? All right, and so if you have an alkane, right, you have carbon-carbon bonds, okay? You need to satisfy the octet for each carbon by adding hydrogen. So let's say I have 4 carbons bonded in a row here, okay? And this is what we mean by straight chain, carbons in a row. So we're not talking about things that are cyclic, which means carbons in a ring structure. We're just saying there's a left side of the molecule and a right side, and there's carbons in between, okay? That's all we're saying when we say straight chain, okay? So let's say we have 4 carbons in a row, and these are all single bonds between the carbon. Okay, well, carbon needs to satisfy the octet rule by adding other bonds. So what we'll notice is these 2 carbons in the middle are going to need 2 hydrogens attached to it to satisfy its octet rule. And then the carbons on the end are going to need 3 hydrogens to satisfy the octet rule. So notice if I put 2 hydrogens on this carbon, now I got 2, 4, 6, 8, right? I got 4 total bonds, 8 total electrons. Over here, I got 4 total bonds. Over here, around that carbon, I got 4 total bonds. Over here, around that one, I got 4 total bonds. So if I have 4 carbons in a row and they're all single bonded to each other, I'm going to end up needing 10 hydrogens to satisfy the octet rule for all the carbons. Okay? So when you have straight chained alkanes, meaning all the carbons in a row are single bonded to each other, that's what ane means. The formula is always going to follow this equation. You take the number of carbons, we'll call it X, you multiply it by 2 and add 2, and that'll give you the number of hydrogens. So notice this was 4 carbons. 4 carbons times 2 is 8, plus 2 is 10, and notice we follow that equation there, and that tells us how many hydrogens we'll need. So if I know I have 4 carbons, and I know that they're all single bonds, then I know I'm going to need 10 hydrogens, okay? So anytime I have 4 carbons in an alkane, I'm going to need 10 hydrogens, okay? All right, so what if I had 7 carbons in a row, and it was an alkane, which means all those carbons are single bonded together? How could I figure out how many hydrogens? Well, we follow this equation, times 2 plus 2. We take the number of carbons, times 2 is 14, plus 2 is 16. So if I had 7 carbons and it was an alkane, this would be my formula, C7H16. And again, it's straight chained, but I'm just going to assume that's all we're talking about right now, okay? All right. All right, and that works for any number of carbons. So what if you had 1 carbon? Times 2 plus 2. So 1 times 2 is 2, plus 2 is 4. So 1 carbon, you have 4 hydrogens. And that's why methane's formula, if we go back up to all the way up to methane, 1 carbon, 4 hydrogens, CH4. Okay? So alkanes will always follow, as long as it's straight chained, will always follow this formula. And that's the only type of carbon, hydrocarbon you'll be responsible for is straight chains. Okay? So what about alkenes? All right, so what happens when you introduce a double bond? All right, so let's say we have 1, 2, 3, 4, 5 carbons in a row, but there's a double bond between between two of those carbons. So we throw in a double bond here. So if we throw a double bond in here, now each of these carbons, instead of needing 2 hydrogens on them to get 8 electrons, they're only going to need 1, right? Because now 2, 4, 6, 8 for that carbon, 2, 4, 6, 8 for that carbon. So I'm only going to put 1 hydrogen there, 1 hydrogen there. But if we count, this carbon's going to need 3 hydrogens, this carbon's going to need to have 2 hydrogens, and this carbon's going to need to have 3. So this is what kind of the structural formula would look like. And if we count, we have 5 carbons, and notice now we have 10 hydrogens. If this had been an alkane, times 2 plus 2, we should have 12 hydrogens. But because we had that double bond, notice we removed 2 hydrogens. If we didn't have a double bond there, let's imagine this was a single bond, then I'd have to have 2 more hydrogens here and here, and then this would be C5H12. But now because I added that double bond, I took away those hydrogens because carbon can't exceed the octet rule, right? It can't have more than 8. So that's my formula, all right? So let's say anytime you have an alkene, and again, we're always going to assume we only have 1. If it's an ene, we have a double bond, but we're going to assume it's only 1 double bond. So if we have a straight chained alkene, all right, the formula is always going to be whatever the number of carbons you have times 2 for the number of hydrogens, okay? So an alkene with 8 carbons would need 16 hydrogens. Whatever the number of carbons are, just times 2. If it was an ane, if this had said ane, we'd do times 2 plus 2, okay? But since it said ene, we just do times 2, and we get the number of hydrogens. So we know the number of carbons, 8, times 2 would give us the number of hydrogens. So again, an alkane with 8 carbons would be C8H18. An alkene with 8 carbons is C8H16. So whenever you add a double bond, you subtract 2 hydrogens. Okay? So if you add a bond, you take 2 hydrogens off of the formula. Okay? So ane is, if ane follows this formula, if it's an alkane, CXH2X plus 2, ene, I add a bond, so I remove 2 of the hydrogens, so instead of times 2 plus 2, it's just times 2. So what do you think the formula might be for ine? Okay, so I add a triple bond, so I got to remove 2 more hydrogens. You guessed it, there you go. Whatever the carbon is, times 2, but then subtract 2 if you have a triple bond, okay? So let's say we have 3 carbons in a row, but this carbon-carbon bond is a triple bond. So let's do it in our head, right? This carbon would only need 1 hydrogen, because right now it has 6 electrons, so it would only need 1 hydrogen to get to 8. This carbon would have 0 hydrogens around it, because it already has 8, 2, 4, 6, 8. And then this carbon would have to have 3, right? So 1 hydrogen there, 0 hydrogens there, and then 3 hydrogens on the one on the end. So the formula would be C3H4. And again, we're following this formula. If it's ine, meaning triple bond, we multiply the number of carbons by 2, but then we subtract 2. So 3 times 2 is 6, but then we subtract 2, 4. That's how we get our subscript for our hydrogen there, okay? Okay, so how do we name them? What's the rules? How do we name hydrocarbons? So first of all, if it's an organic compound, we have to use organic prefixes. So the organic prefixes are meth, eth, prop, bute, pent, hex, hept, oct, non, dec. And the prefixes, these, let me make this smaller so we can see them all. The prefixes here for organic compounds tell you the number of carbons. So if you have meth, 1 carbon. If you have eth, 2 carbons. Prop means 3 carbons, bute means 4 carbons, pent means 5 carbons, hex means 6 carbons, hept means 7 carbons, oct means 8 carbons, non means 9 carbons, and dec means 10 carbons. So you always know the number of carbons from the name, based on the prefix, meth, eth, prop, but, pen, etc. Okay? And then how do we figure out the number of hydrogens? Well, it depends on if it's an alkane, alkene, or an alkyne. We take the number of carbons and we multiply by 2 and we add 2 if it's an alkane. We take the number of carbons and multiply by 2 and that's it for the number of hydrogens if it's an alkene. And if it's an alkyne, we take the number of carbons, we multiply by 2, and then we subtract 2 to get the number of hydrogens. And that's how we do it. All right? So how do you know if it's an alkane, alkene, alkyne? Well, it's pretty easy. You use the prefix to tell me the number of carbons, and then the ending is going to tell you ane, ene, or ine. So propane means 3 carbons, ane means alkane. So prop, 3 carbons, ane means alkane. So I'm following this formula. So if I have 3 carbons, I got 8 hydrogens. All right? But what if it was propene? Well, prop still means 3 carbons, but what does ene mean? Ene means you got that double bond. So now you're following this formula. So if propane is C3H8, propene is C3H6. All right? And then what if you had a triple bond? Well, we would call it propyne. Propyne is 3 carbons, okay? Propyne is 3 carbons. And ine means alkyne, so we're following this formula. And so if I had 3 carbons, then I would need 4 hydrogens. Okay? So it's pretty simple. And again, we're making 2 assumptions. The first assumption is these are straight chained alkanes, meaning they're not cyclical, they're not in a ring structure. Okay? And 2, if it is an alkene or if it is an alkyne, there's only 1 double bond or only 1 triple bond, okay? And we'll make that assumption on any naming test or nomenclature test that you have. So if it's an organic compound, it's only going to be straight chained hydrocarbons, and they could have 1 of the special bonds, okay? That's it, all right? So, well, how do I go from the formula to the name, okay? Well, you would say, okay, 7 carbons, so that's hept. So I got to go back to my organic prefixes and know that 7 carbons is hept, all right? And then you ask yourself, well, which formula is this for? Which of these formulas is this chemical formula following? So 7 carbons times 2 is 14, so it's following this one. So I'm going to call this heptene, right? If this had been a 16, then it would have been following this formula, and it would be heptane. And if this had been a 12 here, then the formula is following this one, and it would be heptyne, okay? So we got to remember these. These are what we got to remember. And if you remember your nomenclature cheat sheet, when it came down to organic, these were the formulas I gave you to remember, okay? So what about C8H14? Well, 8 carbons is oct, and now we got to decide if it's octane, octene, or octyne, and this is following this model. So times 2 is 16, but minus 2 is 14, so we're following that. So that's the formula for an alkyne, and so octyne, okay? So again, it's not that difficult when we make it simple. And for organic, we're going to make it pretty much as simple as we can get, because this is one part of Unit 4. And in reality, if you were going to study organic chemistry, you would take at least 2 semesters of college chemistry. So, so we're trying to condense that all into one little part of one unit. All right. So understand, it can get a lot more complicated, but we're not going to let it. So we still need to know functional groups and all that, and I'll make another lesson about functional groups, but this was just strictly on how to name, okay? Strictly how to name the types of organic compounds that you are responsible for knowing how to name, okay? All right, so that's it. Have a great day.